Here's 10 facts about AI water use to give the issue the nuance it deserves, with citations. 1. There's a big difference between water withdrawal and water consumption. Water can be withdrawn and then returned to the water system and able to be reused like most power plants do. But consumption usually means that it evaporates and can no longer be used as drinking water, or for irrigation and other purposes. Headlines will often confuse this. 2. Green water is rain stored in the soil, usable by a lot of agriculture and grazing. Blue water is from rivers, reservoirs, or groundwater, and that's what people usually fight about. Used for drinking water, irrigation, data centers, and a lot more. Gray water is a term for how much water you would need to dilute out a bunch of pollutants. 3. A 2025 Google report estimates that their median prompt uses just 0.26 milliliters of water, about 5 drops. 4. A viral study estimated that 10 to 50 GPT-3 prompts uses around half a bottle of water, or 500 milliliters, including the power production for it. But that's not one modern prompt, and it's not a single prompt, which people often get confused. 5. US data centers directly consumed roughly 66 billion liters of water in 2023. But that's directly, and models of the amount of electricity they consumed had the power generation consuming another 800 billion liters of water. 6. Hydropower accounting matters. Counting or not counting water evaporating from reservoirs is almost a doubling factor in water consumption numbers, and most people don't mention this or calculate for it. 7. Data centers account for roughly 0.04% of the United States' total freshwater water consumption, compared to 80% for agriculture. It's still just a rounding error, but not for the communities they're being built in. 8. Growth matters, and Morgan Stanley predicted that by 2028, the total water consumption of data centers plus the power that they consume is going to grow by a factor of 11 since 2024, reaching over 1 trillion liters of water annually. 9. Cooling is necessary, but evaporative cooling isn't. There are now closed-loop water cooling systems which don't use water for the cooling of the facility, beyond the initial filling up the tanks. But they can also take more power to operate, which itself takes water back at the level of the power plant, so it's a whole calculus, and climate dependent. 10. Better designs can win twice. Microsoft put out a study of a closed-loop water cooling system, which modeled the whole thing at 15 to 20% less energy consumption and 31 to 52% less blue water. So hopefully we'll move more in that direction. As always, everything needs nuance. Stay curious, stay dubious.